Thank you. I wanted to present information on preliminary results related to centimeter scale collateral damage caused by handheld tools used to cull urchins at Tinker Reef. Next slide, please. So the National Marine Sanctuary Act prohibits, except for certain cases, drilling, dredging, or otherwise altering the submerged lands of the sanctuary. One of the exceptions is lawful fishing activities, which is how the urchins are being culled at Tinker Reef. Next slide, please. We had questions from the sanctuary staff about whether or not this method of culling urchins with handheld tools would damage either other organisms under or adjacent to the urchins or to the substrate itself. And so we embarked on a project with help from the staff divers at CDFW. We used 3 different handheld tools to cull both purple and red urchins of various sizes. We would photograph the bottom underneath the urchin to determine first what the organism or the substrate was prior to the culling effort. Then the urchins were culled by CDFW staff divers. I then photographed the bottom after removing the urchin, and then we were independently scoring these images both before and after the activity by 3 different evaluators to assess the level of damage, if there was any, to the organisms or the substrate itself. And we also quantified the area as a percentage of change using software. Next slide, please. So here's what it looked like when we were underwater. I've got the camera set up, and Dave Osorio, the dive safety officer for CDFW, was wielding the different implements to cull the urchins. Next slide, please. And here's an example of what happens at Tinker Reef, which is a sedimentary rock, if you miss and hit, say, for example, an edge. So the before, next slide, please, and the after. If you've never been to Tinker Reef, the substrate there, as I mentioned, is sedimentary and is very friable and is essentially like the consistency of a rigid chocolate bar. Next slide, please. We also did some of this work on granitic reef. Here was a surprise to the CDFW staff. What looked like rock with worms coming out of it is actually biogenic substrate. So you can see what it looks like before and also what happens after an errant hammer strike hits it. It actually damages the biogenic reef on a granitic structure. Next, please. And I just want to show a couple of examples of some of the organisms and what can happen to them when an urchin is smashed on top of them. So here's a sponge at Tinker Reef. Next slide, please. That's before. Here's the urchin being placed on it. Next slide, please. And then the urchin smashed. Next slide, please. And the urchin's removed, and you can see that there is damage. This is not surprising. This is a relatively fragile organism, but this is why we were doing this, to sort of quantify what kind of damage you could see immediately if an urchin were on a sponge and it was culled. Next slide, please. We also had things like tunicates, which are very, very common at Tinker Reef. So here's a tunicate. Next slide, please. The urchin is on it. Next slide, please. It's culled. And then you can basically, if you look really hard, you're hard pressed to see much damage, if any, to the tunicate. So there are obviously organisms that are relatively resilient to having an urchin smashed on them. Next slide, please. And like that's just indicating that it looks pretty similar to the before shot. Next slide, please. So here are some of the preliminary results. These are 12 different phyla or large taxonomic groups that show that both within and between these different groups of organisms, there's a variation in the amount of damage that occurs. And not surprisingly, if you're a group of organism like the bryozoans, which for the most part are a fragile, brittle organism, then having a hammer smashing an urchin in that kinetic energy transferring through the urchin test down to the brittle bryozoan, it's going to be damaged. There are other organisms, however, that show relatively little damage, such as some of the algae and some of the barnacles that have a hard test or shell that they live within. Next, please. So to answer the question, is there visible damage to either the organisms or the substrate itself? In most cases, yes, there is. So what we've come away with this, and again, we're still in the process of analyzing the data. Tinker Reef is a sedimentary substrate. It's friable and it's easily broken. Brittle organisms such as bryozoans can suffer either major lethal damage or potentially sublethal effects. Many organisms, such as algae and tunicates, show minor signs of damage, and some organisms, like anemones, exhibit behavioral responses that basically say there's nothing that's happening. Next slide, please. And so, in conclusion, there is collateral damage that occurs both to organisms and the substrate. The extent of the collateral damage due to culling is unknown. The magnitude of this damage versus natural damage through storm action, just the regular wave activity, is unknown. And so, except as a legal fishing activity, culling with handheld tools in the sanctuary will likely require a permit due to altering the submerged lands of the sanctuary. So with that, I thank you for taking the time to allow me to present these preliminary results, and I'd be happy to answer any questions. Thank you.